We're going to look at the kinetic energy first, right? And we're going to do a simple calculations, and then showing some animations, right? You have to do the animation. I just provide you the uh, with the file, and then you can simulate using OpenSCAD. Right, the symbol that we use, right? So we have KE in thermofluid and T in dynamics. To be honest, I like to use KE rather than T, right? So I prefer to use KE in all of my lecture. And for potential energy, I'm going to use PE rather than using delta U, using U, right? Right. So this is the kinetic energy for a rigid body, right? So you have a translation component, and then we have a rotational component, right? So basically, this definition of kinetic energy for this case, uh, we are looking at general plane motion, right? So in general plane motion, there is a translation as well as there is a rotation. For particle, we are consider about the half mv per second or translational kinetic energy. For particle, we are not considering the rotational motion of a particle, right? So we can differentiate between particle and rigid body. Now, for the time being, we just consider about particle first, right? We go for the simple one, and then we go for the rigid body. Right. The above show you one particle actually at t equal to 0 and t after certain times. And in between the gray color particles, showing you the translational motion or rectilinear motion in a straight line. So if there is no force, actually when the body is moving, the net force acting on that body is balanced, right? So if there is a force acting on the left, there should be another body also acting on the right. And the net force between the two force will be equal to 0. And the body is moving at constant speed. There is a statement of first law of Newton's, right? So if there is acceleration in terms of a direction, right? When the body is changing its direction or it's decelerating or accelerating without changing the direction, so we expect there will be a net force acting on it, right? So there is work done by the surrounding to the body. And the changes of kinetic energy will be 0 because there is no energy being done on the system or the body being done to the surrounding. Now let's say there is a work done on the body so that it increase its energy, right? Or the body doing some work to its surrounding so that it lost its energy, right? So in the above case, when the body is moving at constant velocity, and then there is a force that resists the motion. For example, let's say the particle, an aeroplane, for example, is moving horizontally, and there is a there is an aerodynamic drag on it. At one point, it's will slowing down, right? Or if you have a disc which is rotating in space, right? Because of the windage, the air resistance on the rotational of the disc, it will finally uh, reduce its velocity until it's stopped. Or let's say if we have a pendulum, right, that swing back and forth as a plane motion because of the aerodynamic resistance, right? Or if the pendulum is attached to a string and you have a frictional effect on the bearing, for example, and finally the pendulum will reduce its angle of rotation until finally stop. Right. So these the coordinate the position vectors at the initial conditions, right? So next we would like to find the position vector when the particle moving translating in rectilinear motions to a distance defined by the constant speed. Uh, Now there is the position vectors for initial condition and final conditions um, for the particle A, right? And at the new location. B is a kinematic description of particle A. We describe it based on the velocity vectors, right? So from these two, from the velocity vectors, we can find that the the particle is having a rectilinear motion, right? So and there will be no acceleration in this case. Acceleration means that you can see the changes of velocity, right, or in the direction. So the final values, you have different values of x dot, and you have a value of y dot. It means there is a force acting on the body. So there will be a work acting on the. It means that the body either receiving energy or loss of one of its energy. Now we look at the potential energy, right? So potential energy means it's talk about the elevation of the body with respect to the datum, right? So this is what I understood in thermodynamics and also understood in dynamics, right? So for potential energy, um, um, so if something is doing work to the body and raise its potential energy, it means that the final potential energy will be higher than the initial potential energy. So it means that the body receive energy from the surrounding. If the body is at a certain elevation and then it fall down, right? So what happens is that um, there is a the energy has been reduced, right? So so the total energy, potential energy will be um, the final minus the initial. D is the practice that we normally do in mathematics. The final value to minus the initial values. So the above here is the animation of the particles, right? From a certain position, and then it fall down uh, to a certain speed, right? Let's say it's stationary, and then it fall down with a certain speed. Right. So we have the state of the body, right? So the initial potential energy will be mg mass times the gravitational acceleration taken as 9.8 meter per second square, and then we have the initial position, right, relative to coordinate frame, initial frame of reference. So in that case, we have the potential energy is equal to 0 joule. So if we understand about this nation, so um, so we can say that the value of potential energy is really depend on where we define the reference value, and then we have the potential energy at final location. Um, so let's say it's below it, right? So the coordinate system that we use right now, based on the common coordinate system that we use. So y is positive vertical the upward, and negative is downward. So in that case, so final potential energy is about minus 490 joule. So the changes of potential energy will be minus 490 joule. Right, from the above, you can see that the potential energy changes is equal to the net work, right? So in this case, we may have many works that acting on the body, but when I explain this thing, I just consider only one source of work done on the body. So, so if the potential energy changes is minus 490 joule, so the these potential energy changes is due to the work done by the body to its surrounding. Or if it's 490 joule, mean the net work is due to the work done by the surrounding to the body, right? So we raise the body higher from it. So it's very important for us when we evaluate the potential energy, the reference, the origin of the coordinate system. Now we look at the what has been written in the book, right? So in dynamics, right? When we study about kinematics of the motion,